Well, I think I finally got on top of the issues with the voltage regulator of the 250TS. It is a rather peculiar device. I'm really not sure what the designer was thinking, or even whether he was thinking at all. It's quite complex, which, considering that apparently the thought behind it was saving money, is a bit bizarre. But anyway, I'll just go through the basic function of the DC regulator side of it, because a lot of this is, well, some of this is associated with the AC side and not the DC charging. So the two yellow wires are the AC input from the alternator, bridge rectifier here. Then there's an SCR or thyristor, a Zener diode which sets the regulation voltage, and then there's a load resistor that gets put across the system in order to limit the voltage. And I've actually drawn a little circuit diagram. This is the basic idea. So this is the AC coil on the alternator. You've got the bridge rectifier, and what's more usual is to have the load device across the AC coil, and it's usually a pair of back-to-back SCRs or a thyristor, which is a more or less a bidirectional version. This is doing it on the DC side of the bridge, which would normally short out the battery, and it would just short out the battery and run the battery flat and probably burn wiring out or blow the SCR. But we've got another diode which blocks that. But it doesn't really necessarily use fewer components. Actually, I should draw in the load resistor. You don't usually have a load resistor on these systems. It's when it's across the AC side. But that's the basic idea. And the rating of the Zener diode, this breaks down at a particular voltage, conducts backwards, turns the SCR on, connects the load, limits the voltage. So I'd replaced the load resistor, which you've seen on the other side. The original ceramic one was up here and had failed either from vibration or corrosion or whatever. It was open circuit. There were a couple of diodes on the underside here which have to do with the AC side, which I'm really not going to go into. But if you recall from a previous video, I thought I had the regulator fixed. I'd checked the components, hadn't actually tried to power it up and test it, but everything appeared to be in good order. Ran it on the bike and the voltage was going up over 9 volts, no sign of it regulating. Well, this is the Zener diode, and I checked that it was still functioning as a diode. And generally, if they're functioning as a diode, they're also going to work as a Zener diode. But I took it out of the board, or rather, the first thing I did was I put this on a bench supply, and you can put DC voltage in on the AC terminals, and gradually wind the voltage and just see at which point this whole system shorts out the DC supply. And it wasn't until 10.5 volts or thereabouts. And when I investigated the Zener diode, it was a 9.1 volt Zener, which is a completely bizarre value to have in a 6 volt regulator where you want the battery voltage to be sort of 7.3 volts, somewhere around that level as a charge voltage. So playing around, with a few values, and I'm now down to a 5.6 volt Zener, and this now cuts in at about 7 volts. So hopefully now when we put it back on the bike, it should actually do the job it was designed to do, but apparently could never do.